Isokinetic dynamometry is measuring the force applied by a muscle group moving at a constant velocity. It is usually done using an isokinetic dynamometer. With this device, a user would strap in and determine a specific angular velocity at which to perform the exercise. As the user's muscle contracts, the dynamometer provides a resistance to prevent the limb from exceeding the preset angular velocity.
Isokinetic dynamometers can be an incredibly helpful machine for athletes and people recovering from injuries or surgeries. The machines are typically very large and expensive and are mostly found in physical therapy clinics or private athletic facilities. For this reason, this technology is generally not used by the average gym goer. Isokinetic dynamometers can benefit people with injuries by helping to restore muscle balance between flexion and extension muscle pairs, as well as reducing the risk of re-injury. Using these machines is safer than isotonic training because the resistance provided by the machine will stop if the user feels any pain or discomfort, whereas in isotonic training, the resistance will not stop until the weight is placed down, which could be too late. Physical therapists use these machines with their patients in order to facilitate the regeneration of equal strength between right and left sides. Using the force recorded by the machine, the therapist can generate a workout regimen in order to restore the strength in the recovering muscle to an equal level of the healthy muscle.
Additionally, athletes can benefit from this equipment in both strength and balance. Strength can be improved because it allows the muscle to be exercised to its maximal potential throughout the entire range of motion of the joint. It can also reduce any imbalances an athlete may have between or within limbs, such as differences between the right and left quadriceps, or between muscle pairs like the quadriceps and hamstring. Improving these balances will improve the athlete's performance as well as reduce the risk of injury. So what do isokinetic dynamometers physiologically measure? These devices determine the strength and endurance of targeted muscle groups by measuring the force exerted by the muscle at specific speeds. In this video, you will see a subject performing an endurance exercise. Muscle endurance is assessed by having subjects perform repetitions at an increased speed for a longer duration of time. By increasing the speed and duration of exercise, the exercise is of high endurance and low resistance, which results in a gradual development of aerobic exercise pathways. The therapists and athletes using dynamometers are interested in seeing how this force changes over time after specific workout routines. Changes in force during isokinetic endurance training can be caused by physiological adaptations, including an increase in the number of capillaries, which means that more oxygen-rich blood will come to the muscles. And second, increase in the myoglobin content, which allows for oxygen to bind to the muscle fibers more efficiently. Now in this video, you will see a person performing a resistance exercise. Muscle strength is assessed by having the subjects perform fewer repetitions at a decreased speed. By decreasing the speed, the subject will have to exert more force to complete the exercise, resulting in an exercise of low endurance and high resistance. This will result in a gradual development of the anaerobic exercise pathways. Changes in recorded force during resistance training can be caused by, number one, changes in the size of the skeletal muscle. So what will happen is that there will be an increase in the size of skeletal muscles, and this allows for an increase in the actin and myosin filaments, which in turn causes sarcomeres to be added in parallel and thus increases the force output of the muscles. Now you're going to see this figure. This figure looks at multiple angular velocities and how the force outcomes relate to the different angular velocities. As you can see, at angular velocities of around 30 and 60, that will be seen in individuals who are performing resistance exercises, where the velocity is low and the force output is high. And towards the end of the graph at 210 and 240, you will see higher angular velocities where the subject will be taking on endurance training with a low velocity, with high velocity and a low power output.
As the user operates the machine, a strain gauge force transducer located at the distal side of the lever arm records the force being applied by the user's limb. Since the resistance force will be applied at the proximal end of the lever arm, this force is recorded as a torque according to the distal distance between proximal end and strain gauge. This recording is then converted to an electrical signal by the transducer. Mathematical algorithms are also entered into the machine to account for the force produced by gravity and inertia acting on the limb. Since gravity is acting on the center of mass of the limb, the equation uses a differential equation that depends on the current angle, which is constantly changing throughout the exercise. As seen in this picture, the gravitational torque in position B will be larger than the torque in position A. The inertial force depends on the preset speed and the user's weight, so an equation is used to account for that force as well. The new electrical signal, which has now canceled out gravity and inertia, only measures the force of the muscle and is sent to a DC brushed motor. Brushed motors are the most commonly used motors for dynamometers because they are cheap, highly reliable, and can run from a DC current. These motors contain stationary electrical magnets, known as the stator portion, that provide a constant magnetic field. The armature, the rotating piece, is several simple coils that are attached to a DC power source through a commutator ring. The ring comes into contact with the power source as it moves across the brushes located at each side of the source. As the current flows through the coil, an electromagnetic force is induced on it according to Lorentz law. This force then causes the coil to rotate. As it rotates, each commutator ring becomes in contact with the power source of opposite polarity, therefore ensuring that the current always flows away from the source on the left side, in this video, and toward the source on the right side. As more coils are added, the rotation becomes more fluid. The electrical signal that enters the coil accounts for the force applied by the user's muscle, gravity, and inertia, and in turn generates a torque within the motor that will resist the user's motion with enough force to ensure a constant speed of motion.
Despite its many benefits, isokinetic dynamometers have several limitations. One limitation is the large size and extremely high cost of the device. This causes the device to only be available in limited locations such as professional rehabilitation centers. The second limitation is that prior to using the device, one needs to be trained in how to use the device. This again makes the device limited to athletic trainers and physical therapists. A third limitation is the amount of time that it takes to perform the testing. This includes both the time it takes for the subject to complete the exercise, as well as the time it takes to analyze any important measures that are recorded by the device. A final limitation is that brushed motors tend to have a low lifespan. This means that the motor may have to be replaced at some point in time.
Overall, there are many main benefits that outweigh the potential limitations of using this device. These benefits include that the device can help strengthen targeted muscle groups by providing resistance training. It can also be used to help increase endurance in targeted muscle groups by providing a high speed of movement. It can also be used to prevent injury by determining and reducing imbalances in muscles between limbs and within limbs. From the data gathered using isokinetic dynamometers, athletes and therapists are able to monitor their training success. Athletes can visibly see whether they are able to produce more force at the same speed compared to before training. And therapists are able to use the data collected to ensure that recovering patients have achieved muscular balance between and within limbs. Knowing this can result in a safer discharge time and a reduction of re-injury risk after therapy. So if you're suffering from an injury or just want to know if one of your legs is stronger than the other, head to a local physical therapy clinic and see if they have an isokinetic dynamometer you can use.